Hello, today I'm going to be explaining problem number 22 from homework number 1, and it's a three-part question. The first part is asking, what is the frequency of a blue light with a wavelength of 450 nanometers? So we're going to do our knowns and unknowns. We know our wavelength is going to be 450 nanometers. We also know that the speed of light is equal to 3.0 times 10 to the 8th meters per second. From here, we know that we're looking for the frequency, and we can go into our equation sheet, and we know that frequency is equal to velocity, in this case speed of light, over our wavelength. And we could almost plug in chug, but we need to convert our units from our wavelength so that they cancel out with our velocity. So 450 nanometers is equal to 450 times 10 to the negative 9th meters. Now we're going to go ahead and plug into our equation. And this comes out to 6.67 times 10 to the 14th hertz, because our meters are canceling out and frequency is in hertz. Now for part B, we're going to do the exact same thing again. So we know our wavelength is 650 nanometers, and we know the speed of light. So let's write our knowns and our unknown frequency. Again, same equation, because it's the same question. So let's convert our wavelength to meters, and that's going to give us 650 times 10 to the negative 9th. And from here we just plug and check again. We're going to cancel, and we're going to end up with 4.62 times 10 to the 14th hertz. And again, let's get its frequency, and our meters are canceling, so we end up with hertz. Now for part 3, it's asking, what is the index of refraction of a material in which the red light's wavelength is 450 nanometers? So it's telling us that we have a red light entering a material and we know that our red light's wavelength is 650 nanometers. So that's outside of the material. We'll put that here. And we know that once it's inside the material, it's 450 nanometers. So our wavelength actually reduced here. So now let's do our knowns and unknowns. And our wavelength, let's not say air. Our wavelength for a vacuum is equal to 650 nanometers. Wavelength in the material is equal to 450. And we're looking for our index of refraction, which is n. Now that we have our knowns and unknowns, we just go into our equation sheet and we find the equation that basically has everything but 1. And we're lucky because we have wavelength of a material is equal to wavelength in a vacuum over index of refraction. Now we're looking for n, So we rearrange this, and we get wavelength of a vacuum over wavelength of the material. We go ahead and plug in. And our unit's are already the same, so we don't have to convert. Oh, let me scoot this up. Okay, and from here, we just solve, and we get 1.44 for our index of refraction. And that's it for problem number 20.